Okay, now I'll share. Okay, so last time we talked about, okay, so there is this quiz. I think it's a relatively, well, if you understand the left-leaning red-black binary search trees, that might be the harder part, but I think the hash table is one of the easier things where maybe the trees, the left-leaning red-black binary search trees might be a little bit harder. But that's up to you to decide. Okay, so let's just look at this first problem right here, the hashing review. And so I just put this worksheet up, and so there's two types of hash tables that we talked about in the last Wednesday, and that was what? That was we talked about linear probing and then the sequential chaining. Okay, which is sequential chaining really is just a bunch of linked lists. Like it's an array of linked lists. And okay, so let's just look at this first problem, problem number one. And that's all we're gonna look at. I actually didn't talk about problem number two in the last hour. This doesn't really matter. Okay. Okay, it's really problem one. The problem one is the one I really care about. Okay, so suppose we have this hash table, and there are the hash, right? So what it is, you have a bunch of, remember what a hash table is? You're just looking for a bunch of, it contains a bunch of key value pairs, and we search on the keys. Just like in a binary search tree, we search on the keys, and then once we have the desired key, we then extract the value. Okay, so and the advantage of the hash function is it can greatly cut down on the number of comparisons, right? So like the linear probing gives us like an entry point into an, instead of starting at 0, we compute the hash code for a key, and then we jump to the index that that corresponds to the hash code, and hopefully the key is near that index. Okay, so okay, whereas like sequential, well, I'll talk about sequential chaining in a minute. Okay, so let's say I'm just giving you the hash codes. The hash code for A is 3, the hash code for B is 3, and for C is 3. So there's only 3 different hash codes. D, E, and F all have the same hash code. G and H all have the same hash code. Now let's just say I was going to put these, so there's, how many keys are there? There's 8 keys. So I was having trouble drawing this in my other, I think some of it is just, sometimes it has a hard time with rectangles, I've noticed. The software I'm using, let's see, does it, see it go to, I think it doesn't like it when I do that. I think I have to lift my pencil off, okay, or the pen, this digital pen. Okay, so there's 8 keys, so the top is going to be the key. No, the top is going to be the index. How many are there? There's 8, right? 4. Okay, so there's 8, yeah, eight keys. Yeah, so we need a table of size 8, and then the key. Okay, let's just say we put this in alphabetical order. Let's say we put A in first, and then B, and then C, and then D, all the way through H. Okay, so A would go at 3, right? So you go to A, the hash code for A is 3, right? And there's nothing at 3, so we put the A here. Now the hash code for B is also 3. Oh, but 3 is filled. We cannot put 2, an array element can only store 1 value, so let's put the B here. And the hash code for C is also 3. Well, 3 is filled. You keep going to the right until it's filled up. And if you get to the end of the array, you wrap around and you go to 0. Well, C, 3 is filled, 4 is filled, so you put the C there at 5. Okay, now let's put the D in. Okay, so the D is, nothing's at 0, so let's put the D here. E is also 0, but okay, 0 is filled, but the 1's empty. F is 0, so the 0 is filled, 1 is filled, and so we'll put the F at 2. And now it's just G and H. Well, G is 6, that's empty. H is 6, 6 is empty and filled, but 7 is empty. Right, and so there we fill it up. And again, if you wrap around, if you get to the end, so you compute the hash code, you go to the index that corresponds to the hash code, and if that's filled, you keep moving to the right till you find an empty array element, And if you get to the end of the array, you wrap back around to 0. Okay, so this is, okay, so notice that it's not one of these 4 options. So it says, which of the following can result from inserting these keys? And the thing is that we don't have to insert in this order. We don't have to go A for, there's no rule that says A has to go first and B. So we can put the keys in any order. Okay, so, but the thing is, if you, no matter where you, but let's look at D, E, and F. I don't care what order you put it. See, D and F just they take up 3 spaces, right? 0, so they're going to go in 0, 1, and 2. If there's like a 4th one, let's say if there's a 4th key whose hash value is 0. Now you're getting to index 3, right? But the D, E, and F never gets past 2. And the ABC never gets past 5. So it's going to take up 3, 4, and 5. And G and H will take up 6 and 7, right? So if there's like another 6 in there, yeah, then you'd wrap around to 0, right? To put them all in. So let's say if there's an I, you'd have to have, let's say if there was an I, and that was also 6, well, then you'd wrap around back to 0. Okay, so the thing that we know is that G and H are in 6 and 7, right? So these two are in 6 and 7. And D, E, and F, this would be 0, 1, and 2. And the remainder, ABCs, this would be 3, 4, and 5. So the solution is, well, first of all, let's just see what has G and H. It doesn't matter the order. What has G and H in the last 2 positions? Well, it's number B or option B or option C. Because yeah, so that's not true for A or D. And now you have to have A, B, C. No, you have to have D, E, and F in the first 3. And so once again, yeah, so D, the order doesn't matter. F, D, E. So F would go in before. So F would be going before D, which would be going before E, and E, D, F. And of course, in the middle 2 are C and A. And again, it doesn't really matter. So these are the answers right here. So it's that possible. So which of the following can result from inserting these keys? How would we get option 3? So again, if we just insert, so just insert in this order. So E, D, F. So let's suppose we have these keys and we'll insert them in this order. So the E would go at, in this case, yes, so the E would go at 0, right? Wouldn't the E go at 0 in this case? It doesn't like that. And then the D would go at 1, and then the F would go at 2, because E, D, and F are all have hash code 0, right? But if you put the keys in this order right here, you get option 3, right? So then you get the C goes at, no, what did we say? Wait a minute, E, D, F. So what's C and A? Oh, C and A. So the C would go at, oh, wait a second. Maybe, wait a minute. The C would go at 3. Yeah, the C would go at 3. Okay, yeah, right there. Hello. And the A would go at 4. A is also 3, but it goes at 4 because the C is there. And the B, which is also 3, well, the 3 is filled and the 4 is filled. So the B would go here at 5. And then the last 2, and what are the last 2? G and H? Well, the G would go at 6, or the G, because G is 6. That's empty. And then of course H. But okay, so that's just an example of linear probing. Okay, and the important thing to understand is that if there's a collision, like A, B, and C all have a collision, they all have the same. A collision occurs when you have the same hash code. A, B, and C all have the same hash code. Okay, but so the important thing is to understand why. Like if A goes at, if we're going to put it in alphabetical order, why B would go at 4 and C would go at 5. So do you have any questions on that? Or, and again, let's say we were searching for C. So let's just use this ordering, let's say we're using this ordering right here. Let's say we're searching for C. Someone's, okay, I want to find key C. Well, you would start it, instead of starting at 0, you would start at 3. So that's the advantage of the hash code. You can start, it gives you an entry point into the array, so you don't have to start at the beginning. And then you keep moving to the right until you find C. And hopefully C is not too far away from C is in an index that's not too far from its hash code. So hopefully there's enough, there's enough distribution in the hash codes that you don't have, it greatly reduces the number of comparisons. So that's the point, is to reduce the number of comparisons. So the initial place for looking for C is at its hash code, and hopefully C has been inserted at an index not too far from its hash code. But that's a whole idea behind linear probing.
I was going to ask real quick, can there be duplicate keys?
Oh, say it again, Philip.
Can there be duplicate keys like AAA?
No. So in this case, it's when the Zybook actually, I used Zybook for Math 140 last semester. They did allow duplicate keys, which kind of see, keys are more like just kind of surprise. I mean, I guess you could do it that way. I think like the keys is like a social security number, like a login name. So like all the login names are unique, or all the social security numbers are unique.
Okay.
So again, so if let's say you when you're putting, so let's say you do okay, let's insert this key value pair, and the key is already there. What you do is you update the value. You don't duplicate the key. So no, okay. So the way we've taught it is that there are no duplicate keys. And so, and the first time I ever saw duplicate keys was in the Zybook. I wrote them about that. I don't know. They didn't seem to be as alarmed as I was. Okay. So they did answer my email fairly fast. Okay. But any other questions? Yeah. But so yeah, for this course, all the keys. Yeah. When we do the searching, okay, the sorting, yes, you can have duplicate keys, but like in selection, sort, and all the sorting algorithms, we can have duplicate keys. But searching, no, all the keys are unique. Any other questions on anything?
No.
Okay, and then let's get to the other review problem. Let's see if I can find it. And so let me know if you can't see this. Okay, so I think I opened up a way so you can, all I have to do is, okay, so, so let's see here. So, and so you see this problem. So you see this problem right here.
Yeah.
Okay. So, and again, we just put in the sorry, my phone is just buzzing away here. Okay, so we just put the W in first. I can't remember if I did this the last hour. So then we put the F in, and then we put the P at the 3. See, this is pretty almost trivial. And O would be a 2, and the E would be a 2. And the M and the I would be at 1. I think it used to be harder. I didn't ask the students I give them a function and tell them to compute the hash value based on the position in the alphabet. I stopped doing that mostly because then, this is an I, by the way, students would make mistakes on their hash codes, and then they have a hard time finishing, they wouldn't really get to the crux of the problem. So, so any questions on that? And that's it. It's really almost nothing. It's pretty trivial. But again, let's say we were searching for P. This is a very small table, by the way, too. Let's say we were searching for P. Okay, well, what? P is in linked list 3. Okay, so all we have to do is we just have to search in linked list 3. Insert, is it F? No. Is it P? Yes. Or maybe we're searching for something that isn't even there. Let's say there's a Q and its hash code is 4. Okay, so we go through the whole linked list, and we wouldn't see we eventually would get to null, right? Because it's a linked list. And but the idea is if you can distribute the keys nicely, then it greatly reduces the number of comparisons. So those are the two strategies that we're talking about. There's some others. I don't know if it's necessarily important I think it's the whole idea of what hashing is. It's a way of greatly reducing the number of comparisons. by kind of putting, kind of keeping, maybe grouping keys according to their hash code. Like in a linear probing hash table, the keys of the same hash code will be near each other. In this chaining problem, all the keys with the same hash code will be in the same linked list. So it's just kind of way, I think, kind of way of grouping keys. And then if you know the hash code, you can go to the, you can quickly go to the, you only have to do is search in the, among the group in the same hash code. So any questions about that? So students, if there's no question about it, let's talk about a new topic here. And let's see here. So I'm going to just close this. Or maybe I'm just going to open something else. So I want to talk about, first let's talk about the predicate interface. And then I don't know if I erased what was in my previous class. So I might erase, we'll see what I did. Okay. Sometimes I write code and I forget to erase it, so you see the finished product. Okay, but okay, so there's a new interface called Predicate, and then I'm going to talk about, and it has one method in it. Okay, so it's built in, and so it's in java.util.function folder, and so there's the interface right there, public interface predicate. It has that generic value, we pass in a class name, and it has one method called test. And it just takes one parameter of type T, where T is the generic variable. Okay, so yeah, so the interface is defined in the package or the folder java.util.function. So yeah, so we get all this code from Eclipse, from Oracle, and it's actually all compressed. But if we actually were to uncompress it, there would be the file predicate.java would be in a folder called java.util.function. Okay. Okay. So yeah. So then, if you're actually going to use predicate in a class, you have to have that import. Can you see I assume you can see this?
Yes.
Yeah.
Okay. Okay, so here, I'm actually going to, let's see, there's just an example here. Why don't we just look at the example online? I guess, because there's really not too much to it, but here's just the, let me just, I wonder if I can go with this. No, I can. Here's just an example of a predicate. And let's just look at the code. Okay, so I'm calling the class, nothing special about the name integer predicate. That's just what I'm calling it. And it implements predicate. Yes, so you have the import statement there. And here's my, this has to correspond to a real class name. And that's your generic variable. And whatever this is, that's what this is, right? They're the same, right? Because isn't that how we defined it? Did I define it? Yeah. T and test T. Okay. Okay, so the predicate interface defines one method called test. It returns a Boolean. So it's going to take, so the input parameter corresponds to this generic variable, and we're going to do something to it, and then do some kind of test on it, and based on that test, we'll return true or false. So in this case, we're passing it an integer, and we're checking, is the integer a multiple of 4? If it is, return true, otherwise return false. And so basically, integer is a special class. So basically, it's turning this class, this object integer, into a primitive integer, like a primitive int, and then just finding the remainder with respect to 4. Okay, so let's see. Okay, so yeah, I'll show you the code in a minute, but I define this class called myList. Where is myList? It's kind of a silly class. All it has is one instance variable. It's an array of integers, and we have a constructor, and all we're gonna do is there's a method called display. We're gonna display all the values in this integer array, we're going to display all the values in this integer array where p dot test is true. So we have this method called display, and the input parameter is a predicate variable. So if it's a predicate variable, that means that the parameter p has a method called test. It returns true or false. And in this case, it's a instance, the generic variable is integer. So p is going to operate. So the p dot test will operate on an integer. So what we'll do is we'll just have an array, and in each iteration of the array, we're going to call p dot test. And if p dot test is true, we print out the variable. That's all we do. So students, let's go to the real exciting part of tonight's lecture. If I can find it, is it this one right here? Okay, I have all these folders and yes, okay, so here is okay, so there's the predicate, right? So just have the code for the, so you'll do something like this. I think I'll post an old quiz tomorrow, but you'll do something like this with the quiz I post on Wednesday. And there's basically, it's all the code I had in the PDF file. Okay, so this test predicate, why do I have a couple other things going on in there. Okay, so return new book, why am I, okay, so this is something else. We'll get to this here. Let me just comment this out before I figure that out in a minute. Okay, so that's odd. Okay, so here is I did another I did some other coding in here, so maybe it's going to confuse things here. So maybe I'll just start. Let me tell you what. So let's just start a new file here, and I'll just call it. I'm pretty sure I put this online. Okay, let me just see if I can format this. Okay, so we have this integer array, and then we have this myList object. This comes straight out of the notes. All it does is we have an instance variable. It's an array of integers. It has one method, the display method, which displays all the values in the instance variable such that the predicate.test is true. Okay, so and in this case, where do I have integer predicate is true. The test method returns true if we pass it an integer that's a multiple of 4. So let's just run this. It should just print out like 0 and 4 and 100. Let's see here. Yeah, 0, 4, 100, 52, and 112. Right. So any questions on that? You might just have to try it yourself. And then, because I had another example I wanted to show as well, if it's okay to go on. So here's this book class. This is actually from your assignment. And so let's look at this. This is what I wrote earlier. So, okay, so let me just, I'm just going to get rid of this for right now. Okay, so there's our display book. And let me just see if I can uncomment all of this. No, this just made it worse. Okay, so I'm going to get rid of all of this. Okay, here, students. I'm going to have to do this by hand, apparently. So it's taking me a second. Then we're going to, okay, so, and then we're going to actually write a predicate. I'll show you this predicate class I have for the book. Just take me 1 second. This is kind of relaxing in a way. Just. I think just one more here. Okay, let's just, oh, hello. Okay, let me just format this, see what's going on here. And why does it, oh, and then the create book is, yeah, it's commented out. Okay, so now I think we're okay. I'm not sure why they gave an error before. Okay, okay, so let's look at what we're doing here. We have this interface called the, no, we have this main method, starts at line 18. Then I have this array of book objects. Then I call display book. And this display book method has two parameters. It's an array of books, which we have defined in line 21. And then we're passing in an argument. See there on line 10? The second argument is a predicate variable. So this P here on line 10, we know has a, because it's a predicate, we know it has a test method, and that the argument to the test method has to be a book. It has to be whatever that generic, in this case, the generic is book. So we know that p.test as an book as an input parameter. And so it's kind of similar to that other example. We're going to iterate through the books array, and if p.test of book is true, we're going to print out whatever bk is. Okay, but what does it mean for p.test to be true? So let's go to book predicate, right? Because that's what we're passing. In line 34, we define the array of books. We start in the main method. You have the array of books. And then in display book, we're passing the array of books as the first parameter. And then we're creating a book predicate object. Book predicate implements is a class that implements book. I mean, it implements predicate. And so and again, so we have public class book implements predicate. We have to have this test class. And I'm saying, well, if the number of pages is greater than, let's make it greater like than 400. Okay, if the number of pages is greater than 400, it's true. Otherwise, so books with at least 400 pages is true. Books less than 400 pages is false. Okay, so let's just run this thing. Kind of a simple thing, simple test, I guess. I think it's this one right here. Yeah, let's just run this. It's pretty exciting. You see, so that last argument is the number of pages. So we have 400. Yes, so notice that all those books are books with over 400 pages. Concrete Mathematics by Knuth, Introduction to Algorithms, Java for Everyone. I made up the book. Those are real books, but the page numbers I made up. Okay. And you can see here, if you look at this array here, where is it? Yeah, you can see there's some books with less than 400, but we didn't see those. And then the next unit that I want to talk about are Lambda expressions. Kind of relates to this, but any question about the predicate interface? I'll put up an old quiz of mine too before you, one or two old quizzes so you can see some more examples of predicate. But it's really simple. All you have to do is write a test method. You just have to make sure you do it right. But most students get it. And then the very last thing I wanted to talk about, we actually a little of course, because I've done it once before, but that linked list is kind of a major topic. So I'll do the linked list next time. Again, it's not required material either. I just want to talk about iterators so you know what an iterator is. So hold on, students. And then you should see, I can't see you. Where are you? Oh, there you are. Okay, so stop. Okay, so now, oh yeah, now I see. Okay. Lambda expression. I'm going to keep this really as simple as possible. So I learned about lambda expressions about 5 or 6 years ago. And I thought the reading was kind of difficult, mostly because it wasn't really a textbook. And some of these Java books, it's like, they'll like write a couple of sentences. Okay, it's like, okay. I think part of it's so simple that it, that there's not necessarily a lot to write about, but I guess there aren't really hardly any examples in the books I was looking at. Okay, so Lambda, and they're really quite useful. So notice how the one thing for the like the comparator and predicate, they're both interfaces where there's one abstract method. So the abstract methods are the methods in an interface we're forced to override, right? They're the ones that just have the method header. Okay, so okay, so by the end of the presentation, you should be familiar with the following concepts: functional interfaces and Lambda expressions. And Lambda expressions are kind of a big deal in the programming world. In my understanding, unless things have changed in the last couple of years, I think a lot of programmers are getting away from, let's say, class hierarchies and writing more interfaces with just one method, and then passing a functional interface, and passing a Lambda expression as an argument when making a method call. Because that's really what, because that's what we're going to see, is that we can use a Lambda expression and actually define a Lambda expression, right? When we call a method, we normally list the arguments. Well, the argument can actually be a Lambda expression. You'll see in a minute. So functional interface, it's just an interface that defines exactly one abstract method. So, so an interface can actually have complete methods, but a functional, and it can also have lots of methods that we have to override. They're called the abstract methods, where you just have the method header, but no actual code for the method. So a functional interface is an interface where there's only one abstract method. And okay, so then in Java 8, now we're up to like Java, I don't know, like 50, 14 or something. But yeah, I think it introduced all these new functional interfaces, one of which was Predicate. And so that's basically the definition of predicate right there. It takes a generic variable t, and whatever this is, that tells you what the input parameter to test is. So also notice, students, this is one thing I want to say. If we're implementing like, let's say we want to implement this interface. The thing is, there's only, well, look, do I have an example on the next page? Let me see. Maybe we can just do it with, I don't do it with predicate, but let's just do it with comparator. Okay, so here's the code for the comparator interface, right? Okay, so what we're going to do is the input class, that's the generic variable, and then what we do is we compare two objects from the t class, where t is, we pass in what t is, like string or integer or whatever. And so remember, this is positive. So if compare returns a positive number, then we say that x is greater than y. Okay, and if it's less than 0, then x is said to be less than y. And here's an example, but for the comparator. So what we're doing is we're sorting this order strings in descending if x appears before y, so this is actually, so this is we're ordering strings in reverse dictionary ordering, right? Like, so if you actually had a bunch of strings and you were sorting them from smallest to greatest, the words at the end of dictionary would come before the words at the beginning of the dictionary. So like in this case, zebra is less than, let's say, like cat, because cat, the earlier you are in the dictionary, the bigger you are, right? Because we're doing minus compared to. See, normally zebra, the compare to method is the compare to method defined in the string class, and that returns a positive. So this would, I'm leaving out the double quotes. So see, this actually returns a positive value. And so like zebra dot compare to cat is positive. You multiply by that -1, it returns a negative value. So in this case, zebra dot compare to, so in this case, compare, so let's see here. So that would return a negative value. So in this case, compare, my printing is terrible. So let's say we did compare zebra cat. Yeah, we would get a negative value. So in this case, zebra is less than cat. So that's the whole point of this comparator. We can compare strings any way we want. Okay, so okay, I'm kind of digressing here, which I do a lot. Okay, but the whole point, the thing about the comparator is, so look at this right here. There's only one creative part that we add to this. And that's this thing, the part after the return. That's the only thing that the computer can't do on its own. So if I said, hey, computer, I want to write a class that implements comparator where the generic variable is string. Well, the class will go, okay, well, I'll just generate some code, public class. I'll give the class a name. I'll just call it. And there's nothing special about compare strings. Okay, public class, some class name. Well, this is a def, and it has to say the word implements. And after implements, it has to say comparator string. And we know it has to have these curly braces. Well, we know it has to have an int compare method. And if the generic variable is string, we're going to have two input parameters to compare, which are both strings. We know we're going to have this return statement. The only thing we don't know is the computer on its own doesn't know what to put after the return. That's where we come in. That's the only, so if you look at this whole thing, I mean, it's not like it's a lot of lines of code. This is the only thing that the computer needs us for, right there. And so that's where the Lambda expression comes in. The Lambda expression basically just removes all the code that isn't necessary. You know what else isn't really necessary? It's even the parameter names. I mean, not the parameter names, the parameter types, because we know the parameter types have to agree with this. We do have to give we have to give some kind of name to the parameters, like variables in a word problem. We have to have something to hold the data. Okay, so that's what Lambda expressions do, and they just remove everything that isn't necessary. So here's an example of a Lambda expression right here. I'll talk a little bit more in the next slide. And so when you see this symbol, that's actually two keystrokes on the computer monitor. So there'd be like a dash greater than. I think the greater than is above the period. Okay, but when you see that, that means Lambda expression. Okay, so what kind of Lambda expression is it? Well, we're signing it to, it's a comparator string. That means the input, that means X and Y. Those are the input parameters. And so what we're defining here on the right, let me just erase this. What we're defining here on the right is that we're defining the compare method. This is the compare method. We're defining remember what we said, a functional interface is an interface that only has one abstract method. That's basically what we're doing. We're defining we're defining the contents of the abstract method. Now, my examples are really pretty simple. It's just one line. You can make it so it's several lines of code. We're not going to do that. So a Lambda expression just doesn't have to be one line. But to keep things simple, I'm doing it that way. So, so the input parameters are called X and Y. And again, implicitly it's string, right? Because that's the generic variables class right there. You could type string X, string Y if you wanted to. But let's just take out the stuff we don't need. And then, so here are the parameter types. And then we're returning, we're not actually saying return, we're returning minus X dot compared to Y. Right, so this is what goes in the return to the compare method. So so in this case, okay, so this was yeah, so this is defining a comparator where the strings it's reverse dictionary ordering. Zebra is less than cat, or door is less than cat. So what are we doing here? We're going C dot compare, right? The name of our comparator is C. It's got a compare method. And so it's going T dot W. So basically, your T is X. Basically, what it's doing is it's returning minus T dot compare to W. In this case, it'd be minus cat dot compared to door. So cat dot compared to door is negative. So this actually returns a positive value, right? Minus, I'll leave off the double quotes. See, door is bigger than, so cat dot compared to door is positive. So minus cat dot compared to door is negative. Wait, I'm sorry. Cat dot compared to door is negative. Yes, wait a minute, that's not right. This is negative, right? Because cat dot compared to door is negative. and you multiply by minus, the whole thing is positive, right? So this returns a positive value. So cat is greater than door. So students, that's all there is to lambda expressions. Now, let's just talk about this. So if you're having a hard time, let's see if we can do one. Let's see how you can go backwards. Okay, so let's just talk about this one slide. So the lambda expression defines the comparator. So for a comparator, the lambda expression defines the compare method for a nameless class that implements comparator. Okay, and so when you see that expression, yeah, so the lambda expression defines the compare method for a nameless class that implements comparator. So you see this, first of all, that's what tells us, that means lambda expression right there. And so that's mapped to the following method, right? This goes for there, that's your first parameter, that's your second parameter, and this is what goes after the return. So we took away the public and the int and the parentheses, we took away the defining the parameter types, and we took away the word return and all the braces. So we're just typing in what we have to type in. Okay, so let's just look at, okay, so here's an example of a lambda expression. Let's try this one. Let's see if we can go backwards. Okay, so we're going, so what do we do? What does the compare method do? So let's see if we can write the comparator. Okay, so let's say, okay, I got this comparator, I mean, this lambda expression stuff is kind of hard. Okay, let's see if we can actually write the equivalent class. But in this case, this is positive. When would this be positive? Right, when the length of s is less than the length of t, right? Because you're subtracting s from t. So when this is, I mean, s is the first parameter. So this means that the compare method returns a positive value when the string in the first argument has fewer characters than the string in the second argument, right? So the fewer characters you have, the bigger the string you are. And that's how we're defining it. But let's just try this. So let me just take a picture of this in case I need it. Okay, so let's just open up Eclipse. I might actually have this typed in here, but I want to do it again. Okay, so let's just look at this. Okay, so test predicate, and then so this was, okay, this is the one we had the bunches. Okay, so let me just define an array of a bunch. Yeah, so we'll do this right here. Okay, so there's this method called arrays.sort. So I'm just going to cancel all this out. Let's just put this down here. Okay, so let's say we have a bunch of arrays, a bunch of strings here. Cat, let's make it different lengths. Now, let's make it all the same case. I think I do this in a different order. Door. Okay. And maybe one more. How about, I don't know, house. So the words seem to be kind of nicely, I think it's kind of a decent distribution. Okay, so now there's actually this method called arrays. I think we've talked about this, arrays.sort. And we're going to put in an array. And then there's an overloaded version where we can actually, so we're going to do two versions of this. Okay, so, well, first of all, this was my lambda expression here. Let's hold on. Let's just write the lambda expression first. I said we go backwards. Okay, so let me just do this. I actually have a string comparator class, so I'm just going to erase all of this, and I'm going to, okay, so let's just erase this. Okay, so there's my string comparator class, and this is the one that was in the notes. So there's the lambda expression because it's got that, dash greater than in the comment. How could we write a compare method, right? So if I say, let's write a string comparator, let's implement comparator string. Okay, so You have to write some class name, public class string comparator implements comparator string. Now we know it needs a compare method. So public, and it's going to return an int compare. Okay, so the names our parameter names are S and T, so we'll go string. We have to type in string now. Methods actually you have to put the data type in. And then we just go return, and whatever after that dash arrow, that's what we put.
Wouldn't it be string S, string T?
Okay, say again?
String S and string T.
Oh,
in the
that's my
egg.
problem, yes.
Yeah.
Thank you. Okay, so again, so here's your lambda. This is the lambda expression right here. Just kind of shoved it. Again, and then just how I think it was pretty easy to go from that to the compare method, because what's to the right is just what's after the return. That's in here, just your parameter names. You just have to type in public and compare. So so let's just see here. So let's go back to our. Okay, so now we're going to so let's just try that. Okay, so let's just sort in ascending order by length. Okay, so do I have? Well, I'm gonna have to do an import statement here. So let's put our lambda expression in. So string is an array of strings. So let's just call the parameters x and y, and then we're going to put dash, and then we're going to do a lambda expression. And so we're going to go reverse diction. So we're going to go y dot length minus x dot length. Okay, and then oh, does it already have that import statement? That's odd. I don't see. It should have. You should need a statement that says import. Okay, kitten. Okay, sorry. Yeah, I'm not doing anything to the cat. It's only 6:52. She doesn't get fed for over an hour. Okay, so anyway, I don't understand why I'm not getting an error message.
Is it because it's collapsed?
But it should say red. It should be something red. What I'm saying is I'm surprised let me say, maybe I haven't saved it. Let's see what happens. Let's see what happens when I try running it, okay? Okay, so I've sorted the array using, see that second, oh, I know why. I thought I would need to import the arrays. I thought java.util.arrays. Okay, well, let's see what happens. Okay, so we did this sorting, and now let's do a for each. So it sorts in place. So for each a string s in str, let's just okay, so let's just print. Okay, so it should print out in descending order by length now. Because the first one that's printed out is actually considered to be the smallest. Well, that is so strange, unless there's something I'm not seeing here. Well, I guess it's kind of not the important point of this discussion here. Oh, you're right. I think this is what you're talking about. Is that what you're saying, Jose?
Yeah, it was collapsed.
Yeah, okay. Yeah, I didn't notice that. Yeah, there's something wrong. Either that or everything I know about Java is going out the window. Yeah, 20 years, 30, yeah, almost over 20 years of knowledge down the drain. Okay, so anyway, okay, but see the great thing about notice that we did not have to create a class that implemented compare rate. We didn't need a separate file. Okay, so let's just do this again because we're really enjoying this so much. Now let's sort, let's say descending order by descending dictionary ordering. Descending dictionary ordering. So in this case, we go, y is the second one. So we could go, how does minus x dot compare to y? And now let's just run this again. then it's the exact same thing. What did I do wrong here? Okay, so let's do, what did I do wrong? Okay, x dot, or maybe it just happens to be the largest one is, or maybe it's just a coincidence that the, okay, I didn't like that. I don't like that at all. Okay, so let's put that's just a coincidence. I go, what? It's not a bug, it's a feature. Okay, so is that what they say? Okay, so let's put a Z, how about ZE? And then let's put a, I don't know, how about story? Okay. Or stories, okay. Now let's try running this. So the first time it should be in descending length order. So should we go from, we'll go from longest length to shortest length, and then we'll display from Z all the way down to A. Yeah, see, the first time you see stories has the most, what is it, 7? And then Y is 5, house has 5, door 4, cat 3, AN 2, ZE 2. Okay, so now the second time we displayed in descending order by reverse dictionary ordering. So the Z comes, so the first one that you see displayed is the smallest. So Z is the smallest in Y, and then stories, and then house and door, cat and N. So, and let's see here, I don't know if we can do one more here. So, and if you wanted to do ascending order by length, we could do this. It doesn't take that long to do now. All you have to do is reverse the role of X and Y. I think that's it. Okay, so, all right. Oh, I didn't put a space in there. I thought we could do one more here. Did I not put a blank line here? Okay, so let's just do it one more time so the output's easier to see. And I thought we could do one more and then maybe just, that'll be it for listening to me going on and on. So the first one was descending order by length. The second was descending dictionary ordering. And then the third one is ascending order by length. So, but the remarkable thing is that it's just, we don't, I don't know, I did put the debugger on by accident. Oh, well. Okay, so I didn't mean to do that, but that's fine. Okay, yeah, but the thing is, it's very easy to create a new sort criteria. So and let's just look at this other one here. So we have this. Okay, so did I get, oh, which one is this? This is, oh, here. So let's see here, students. Let's see, how did let me just, let's just close this here. Let's open this up. And let's see here. And then, let's see, how do I get out of this? I'll tell you what, let's just copy this code into here. I did something. Let me just copy this code into here. Okay, here, so sure, how somebody got, oh, I thought I didn't really want to be in debug mode. I wonder if this will allow me to do this. All right. Okay, so so we have this book, and yeah, we have, oh, I need the create book from here. It's only take me a minute. Okay, and so let's get rid of this right here. Okay, so we have this book here, and so then what do we have? We had test. Oh, sorry, students. One more thing here. Sorry, it's kind of. Let me just do this display book. Okay, so let's see if we can do a lambda expression for the book. I didn't do that in the last hour. So let's see if I can do this off the top of my head. All right. Okay, so the second argument is a predicate. So let's see if we can display all the books, and then what was our book predicate? The number of pages is over 400. Okay. Okay, so we're going to call, let's see, we're going to call it display book. It's the name, and then we're going to pass in BKARR, and now we're going to pass in now the test, and for the predicate, the test method only requires one parameter. We don't have to put parentheses around it when it's just one parameter. So I think I can. Let me try it. So we're going to go, just to be consistent here, I'll just do, I'll show you, you don't actually need this. So you go B dot get num pages greater than, I can't remember, let's say 380. Okay, it doesn't really matter. Okay, so let's just run this and see there, see that second argument on line 35, that's a lambda expression, right? You got the dash and the arrow, and all we're doing is what's after the dash arrow is basically, is just, you know, it's what would go after the return. So I did greater than or equal to 400 in there. Okay, so I guess I can do greater than or equal to 400 here too. Okay, so let's run this. Yeah, it's we see all the books whose number of pages is greater than 400. Can you still see me?
Yeah.
Yes.
All right. So where were we test predicate to? Okay, I just wanted to show you. Now that one last thing I'll just say, if there's just one parameter, like when you're writing these lambda expressions and there's just one parameter, I don't think you need to put parentheses around it. Yeah, you don't. So it's not giving me an error message. If there's more than one, yeah, you're forced to put parentheses around it. All right. So now you know everything there is. You know more about lambda expressions than you did when you started, probably. But so we'll review this again on Wednesday, and this will be not the quiz for today, but the next quiz. Any questions right now?
I was just wondering, so the purpose of Lambda is just more shorthand coding, just?
Yes,
is that,
absolutely.
okay.
Yeah, the lambda expression, basically what we're doing is that we're passing as an argument there on line 35. Essentially, we're passing in a method as an argument. So instead of writing a whole class, we just pass in them. So also look right there on line 9, that display book, like the display book method. You see how the second argument is a predicate? The predicate, basically, we're just passing in the code for the compare method. So you can think of like that second argument as like a function or a method. So we're passing in a method as an argument, but yeah, we don't have to write a whole class, or we can just write the contents of the method and pass that in as an argument. Does that answer your question, Philip?
Yes, it is.
Okay. And you see that in other languages as well. I'm pretty sure they have this in Python. In some ways, they've actually had that in C, where you can have like a function to a pointer. And I think, remember in Fortran years ago, you could pass in a function as you can define a function with one of the function parameters can be one of the parameters to a function could be another function. So Fortran's had that for a long time, even though no one uses it anymore. So I think this is kind of, but these lambda expressions are kind of a big deal, and definitely Python and this language have it. So anybody else? I might stop sharing. I might stop the recording.